everyone. The topic which we are going to see today is gravitation. In many occasions you would have come across this term gravitation. Today we are going to make a complete analysis on this topic. First of all, we'll just see an introduction on gravitation. See, this is Earth. Any object that is above the surface of the Earth will drop towards the Earth. We know why. Because each and every object in this universe will get attracted towards the other objects near when it is brought near to them. Therefore, if any object is separated by a distance between Earth and that mass, this object will get attracted towards the Earth. You may have a question, why the Earth is not getting attracted towards the object? Because of the mass of the Earth. Since mass of the Earth is higher and mass of this object is lesser, this object gets attracted towards Earth. There is a proof for this also. That is, force. We know that force is equal to mass into acceleration. The acceleration of the object and or Earth, it depends on, see, acceleration is equal to force divided by mass. This mass will move on to the opposite side. Therefore, force divided by mass. Therefore, mass is inversely proportional to acceleration. Therefore, if mass is higher, acceleration will be lesser. Therefore, Earth is not getting attracted towards the object and the object is getting attracted toward the Earth. And next important thing is, we need to analyze the force between these two objects. That is the gravitational force between these two objects. To analyze that, I am going to take two different objects. This is object 1, that is mass 1, and this is object 2, that is mass 2. These two are separated by a distance. We have to take the distance in the center, towards the center, not to the surface of the two objects. Okay, these are separated by a distance d. Therefore, whenever two objects are separated by a distance, these two have an attractive force. That force is called as G, force Fg. Therefore, we have two different parameters, that is mass and distance. Therefore, we are going to make an equation between mass and distance for the force. Therefore, force is directly proportional to mass 1 and product of mass 1 and mass 2. It is because if the mass increases, force will increase. If mass decreases, force will decrease. Therefore, force is directly proportional to product of two masses. And similarly, force is inversely proportional to square of distance between them. It is because whenever the distance are increased, what happens is the force between these two will get decreased. Therefore, when you look mass 2 with respect to mass 1, there is a distance d, and similarly mass 1 with respect to mass 2, there is another distance d. Therefore, 1 by d into 1 by d is equal to 1 by d square. This is called as inverse square law. These two are equations of force of gravitation. When you link these two equations, you will get gravitational force Fg is equal to, that is directly proportional to product of masses m1 and m2 and inversely proportional to square of distance between them. Since we have to remove this proportional, I am going to introduce a constant, that is G, that is universal gravitational constant. Fg is equal to universal gravitational constant G into product of masses m1 m2 divided by d square. Lord Cavendish introduced this gravitational constant value G is equal to 6.673 into 10 to the power minus 11, and the unit is, we have to calculate the unit. Therefore, keeping gravitation G on this side and moving these three parameters on the opposite side, you will get G is equal to Fg into d square divided by m1 m2. Therefore, unit will be, force is Newton, distance square is meter square, divided by mass 1 and mass 2 m1 and m2 will be kilogram square. Therefore, this is the unit of universal law of gravitation. With this, we complete the gravitation topic. Hope you have understood the concept. Thank you.